Now in this video we're going to start talking about multiple angles. Now you need to refer to your addition of trigonometry, addition theorems that was on page 271 of your textbook. So if you have a look at them, you'll be able to answer these questions effectively. First of all, here is a basic example. Show that cos 2x equals 2 cos squared x minus 1. So let's work our way through that. So left-hand expression, I'm going to write the left-hand expression as cos of x plus x. So there's our 2x. Using the expansion, that's going to give me cos x times cos x. Take away sin x times sin x. So far very good. We're getting closer. We need cos squared x, we've got cos squared x, we've got this sin squared situation in here. So what we're going to do is we're going to use the fact that sin squared plus cos squared is equal to 1. So since I don't want sin squared, I'm going to rearrange this. Sin squared x is 1 minus cos squared. So there's my replacement factor. I'm going to take sin squared out and put its equivalent in its place. So therefore, I now have cos squared x, take away 1 minus cos squared x. Take away is a plus, so I now have 2 lots of cos squared x. Take away 1, which equals my right-hand expression. So that's the type of stuff that you'll be looking at. Now, from that, there's a few that you should just remember. For example, with the cos 2x, there's a few of them that's worth remembering. This is one of them in particular. We should be able to show that cos 2x, through our working, at one stage we got down to this. Cos 2x is the same as cos squared x minus sin squared x. Worth remembering. It's also equal to what we've just demonstrated. 2 cos squared x minus 1. And of course, instead of replacing sin squared, had I replaced cos squared, I would have ended up with 1 minus 2 sin squared x. So there are 3 identities that are worth remembering. Another one worth remembering is 2 sin x cos x. And the last one, tan 2x. So those 3 are all worth remembering, and they'll go into what we're going to do. Now, give me a moment, I'm going to clear the board and then I'm going to show you how to use this in a more advanced problem. Now, believe it or not, what we've just done, this work here, is going to be useful in doing these integrations. Now, we know that sine differentiates to give cos, and cos differentiates to give negative sine, so therefore the integrals of those are very, very easy to do. Sine squared and cos squared, not so easy to do. We've got to find a workaround to try and get our way through that. So what I have here is I have sine squared of some particular angle. Sure, the angle might be a function, but it doesn't really matter. It's still sine squared of ultimately an angle. So I go over here to these multiple angle formulas that we've started with. Sine squared of an angle, I can find this here. So there's sine squared of an angle. And I can work backwards to that to see that it's cos 2 lots of the angle. That is going to be very, very easy to integrate. So I can take this out and replace it with something in this particular format. So what I want to do is I want to use the idea that I'm looking at, I want to eventually get to cos 2 lots of my angle. So I'm going to work on this particular principle. So what I'm going to start off is, I'm just going to replace that with y. So I've got cos 2y. Is, according to this, would be equal to 1 minus 2 sine. So I want to take my sine squared out and replace it with the cos squared. So I'm going to rearrange this to make it read 2 sine squared y equals. Cool. Now I can take my y out and put the angle back in. So 2 sine squared 3x. I'm going to replace that with 1 minus cos 6x. So I can now take out sine squared 3x and replace it with 1 minus cos 6x. Now that is a much easier integration to do. It's just 2 functions added together, integrate each of them individually. Integral of 1 with respect to x is just x. Now, we know sine differentiates to cos, so cos will integrate backwards to sine. So negative cos will integrate back to negative sine. The angle will stay the same. Now I know when I differentiate a trig, I've got to multiply through by the differential of the inside function. So I integrate, I have to do the opposite, which is divide through by the differential of the inside function. And of course, plus c. So there's a type of work that you're going to be doing. You'll be able to use these multiple angle formulas to be able to do more complex integrations like this. Now, before I go, have you heard of the bands going around? It's called 1023 megabytes. You probably haven't because they haven't got a gig yet.